हामी चाहिँ अब टुडे वी आर गोइङ टु स्टडी अबाउट द टाइम डिपेन्डेन्ट श्रोडिङ्गर वेभ इक्वेसन टाइम डिपेन्डेन्ट श्रोडिङ्गर wave equation. This time dependent Schrödinger wave equation is necessary to find out the what will happen to the wave function within the given course of time. Means that what will happen if we apply the some sort of perturbation for certain time. What will be the changes in the wave function of the given system. For this we have general form of wave equation in terms of space and time. Let us consider for one dimensional system that is psi xt is equal to a e power exponential power I iota into kx minus omega t. As k is, as we familiar with, k is equal to p by h cot, where p is momentum, h cot is reduce Planck constant, Planck's constant. Then omega is, as we know, that E by h cot, that is energy equal to omega into h cot. Omega is equal to angular frequency. As we trying to find out what is the relationship of this time dependent wave function with the Hamiltonian of the given system. Let us take it equation 1. Let differentiate equation first with respect to say time t. Then we have partial differentiation that is d psi by dt is equal to a into d by dt del by del t into e को power में exponential को power I kx minus omega t. Derivative of this term will be, this term is constant, we have to derivative this last term only. D by dt exponential I by h cot, putting the value of k and omega from this. K will be px minus et. I by h cot is constant term, so we have to take it outside of this system. So I by h cot, exponential derivative will be exponential I by h cot px minus et. Then differentiate d by dt px minus et. Then we will have I ai h cot exponential I by s cot px minus et. Derivative with this term is constant term. We have to partial differentiation with respect to time only. So minus I minus e is the constant term. So put this in the here, then we will get I s cot ae exponential I by s cot px minus et. Then partial differentiation dt is equal to minus a I by s cot a e exponential I by s cot px minus et minus e I by s cot a exponential I s cot px minus et. Since from first we can write this term, we can replace this term by psi. So we have I e by s cot into psi xt. That then we can write it s cot upon I d psi xt equal to e psi xt minus sign. Then multiplying left hand side by I by s cot I by I, then we will have minus s cot by I into I by I, that will be equal to minus I s cot by I square. As we know that iota square is equal to minus 1. So you can replace I s cot upon minus 1, that will be equal to I s cot. I s cot d psi by dt is equal to psi e psi xt. Let's denote it as a second equation. Then differentiate equation first with respect to x, means that double differentiation that is d square psi by dx square equal to what? We have to find out this term. We have psi xt is equal to a e power I by s cot px minus omega e et. Then d psi by del x is equal to a e to power I upon s cot px minus et d by dt I by s cot px minus et x. We have to derivative with respect to x. A e power exponential I by s cot px minus et. This is constant term, it is constant term, so that we have to differentiate only px term. I upon s cot is constant term, I upon s cot is constant term, into p, x derivative will be equal to 1, minus e and t is constant term, so its derivative will be 0. So I by s cot a e I by s cot px minus et del psi by del x. Then again differentiate this equation with respect to x. Then del square psi by del x square will be I p. Yeah, here is p. I by h cot into p a equal power I by h cot px minus et d by dx. Then we have d square del square psi by del dx square will be equal to I by h cot p a d del by del x into eको पावरमा I upon h cot px minus et. I by h cot pa dot derivative of this will be I upon h cot px minus et dot I upon h cot into p minus 0. Then I upon h cot square p square a equal power I upon h cot px minus et. That will be equal to the minus 1 by upon h cot square p square a e power I by h cot px minus et. Then this put this value in here in left hand side. H cot square minus h cot square d square psi by d x square equal to p square a e power I by h cot px minus et. As you know, this can be replaced by psi xt. Then p square psi xt will be equal to minus h cot square d square psi by dx square. Then as we know energy will be equal to p square by 2m. Then this taking equation 3, then multiplying this equation by psi xt, then e psi xt will be equal to p square by 2m, p square upon 2m into psi xt. As we know from equation 2, this I h cot d psi by dt is equal to e psi xt. So we can write I h cot d psi by dt is equal to p square by 2m psi xt. Or 2m I h cot d psi xt upon dt is equal to p square xt. Since from third we can write 2m I h cot d psi xt by dt will be equal to p square x psi xt we can write minus h cot square by h cot square d del square psi or del x square. Therefore we have, then this value is upon goes on this like h cot minus I h cot square by 2m d square psi by dx square will be equal to the I h cot d psi xt upon dt. Then for one dimensional box Vxt will be equal to 0. We can write minus s cot square by 2m d psi x square plus v vxt psi xt, that is equal to I s cot into I s cot d psi xt upon del t. We can replace del square by del x square by Laplacian operator with respect to x component. This is Laplacian operator with respect to x direction. So I minus I s cot square by 2m del x square plus v xt psi xt psi is equal to I s cot d by dt psi xt. For three-dimensional system, minus I s cot square by 2m, we can write del x square plus del y square plus del z square psi xt plus v x y z t into psi xt, that will be equal to I by s cot d by dt psi x y z t. We can replace this term by del square, del x square plus del y square plus del z square in psi x y z t by psi r t. Therefore I s cot square by 2m del square plus vrt psi rt will be equal to I s cot d by dt psi rt, which is required equation for time dependent Schrödinger wave equation.